Yes, this is my third video I've made on my solar trough. This is a water heater I'm using for it's a pre-hot water um, system I have. I can heat my water before it dumps into my existing gas LP tank then too. Um, I know in a house, probably, I don't know, 35 to 45%, depending on your location of your energy, goes into heating water. So we're talking about a lot of cost and expense just to heat water. And I guess I could never wrap my brain around that we keep our water at 140 degrees, and yet I'm dumping in 55-degree well water to this water, and sure enough, yeah, it takes a lot of energy to get it all back up to 140. So I did do an earlier video that talks about a lot of the plumbing and how I interfaces into my existing tank, and why I'd use this system instead of say electrical one, or this. I had to use what I had. Okay, and so I have the 80-gallon tank, and my idea here is trying to get 80 gallons of hot water to get me through a day or two of cloudy weather. And if it is cloudy or snowy for a week, well, the existing hot water heater still works. So and these three panels you see here, these are the ones that actually go to the photovoltaic. um, these are 300 watts each. This one down here, this is just a 100-watt panel, and this is what powers this system. With the exception of the CPU, I actually used a little bit different system just to get the ADD to settle down a little bit here too, and I'll talk about that here too. So what I did, I got rid of my jungle down here, put down weed block, and I filled this full of white gravel because I think that's going to be the best to reflect the light in the summertime. You can see it's reflecting here just from this picture, from this viewpoint here too. These panels are more, the angle of incidence is set up more for wintertime than it is summertime. Um, and I have to say, I've been real happy how well these things are working. But boy, since I added this thing about 6 weeks ago to it, it is so much better. In fact, I think my high temperature on the tank was 155 degrees. Now I have a thermal cutoff, solid state relay that takes the photovoltaics offline at 150. But since I'm measuring the water coming out of the tank and not in the tank, sometimes it can come out a little bit hotter because it's not. It takes a little bit to heat that tube up then too. So anyway. So, what I did here a little different here too. I wanted a system that had a small footprint. Okay. Now, most of these solar troughs, many of them I've seen on the red arrow here, that's the access point, and it all revolves around that point. Well, if I were to make that the access, I would have to build a much bigger structure. And because of where I'm putting this solar trough, it probably would interfere then in the wintertime with my photovoltaics back here. Being that I can actually redesign it or design it to be the access on the bottom down here, it just rotates around that point. That made a lot smaller, simpler structure for me to design then too. And I have to say, it's even though it's not too heavy. I think I weighed these mirrors are 4.4 3/4 pounds each. So we're not really talking about that much weight, and they are kind of balanced, but there's enough power. I think my linear actuator will take up to 400 pounds, and I'm not even coming close to that. So I'm real happy how well this is working then too. So the video, let me back up 1 second. What makes this work, okay, are these magnetic rotary unions. I have a video coming up here too, but I didn't even know this technology even existed. Okay, and I was like skeptical. I was like, oh, come on, it's got to leak a little bit. I've seen some hose reels and things like that, and I cannot believe how well these things are. These are rated at, I think, 4,000 psi at 250 degrees. As long as you keep the RPMs down less than 160, I'm only going through about 70 degrees maximum very slowly, so that's not a problem. And I've actually had no problems with these things, not a single drop, not a single leak. So I've been real happy with this. Now here's the video I was talking about then too. So this will show you, I get it running here. It's not a real fast speed, okay, but I don't need a fast speed. Okay, and again, it's rotating around that spot. And what I have here, this is the output side. Okay, I probably could have redesigned this better, have the output over here, but this is just the way it worked out. Um, this is just early in the morning, so it's just getting started right now here too. So, but Yeah, this I have a manual override control on my control section, and this is what I'm using right now. Basically, just to override it up and down then too. And sometimes if I know it's going to rain, I'll leave it down. I even thought about using a rain sensor so that when it detects rain, it will lower it down and drain all the collectors. But it's not really been that much of a problem. So the this is the Rotary Unions I'm going, and this is the output pipe here too, and they just revolve around that spot. There's really no connection to here. I'm just kind of holding it together with a bracing down there and some really some insulation to help hold it in place. But the plumbing really kind of holds this right where it needs to be. And this little structure here is just more for alignment, keep it placed in too. So you can see a couple different versions of the mirrors. This is some of the earlier mirrors I used. I used to use angle iron, angle aluminum, I should say, and welded them up. And some of my first ones, in fact, my very first mirror I stuck on here is still on here, and it's been doing well for over a year now. And it's been packed with snow, it's been filled with water, and it's just like, yeah, it's been holding up really well. I know I don't like standing water on this system here too, so, but I redesigned these. I've gone through 3 or 4 different designs. This is one of my latest ones here too, that instead of actually using the angle up, I actually flipped it over, trimmed off one edge because I couldn't get the measurements I want in the 6061 aluminum, and welded them up then too, and then caulked them from the bottom. That gave me a much less of a lip, so it's not going to hold near as much water, and it will drain much easier when I do raise it up then too. I am now using 6063 aluminum that I can get in the right measurements, so I don't have to do any trimming or cutting, and that made it much faster. It's not really, 6063 aluminum is not really classified as structural, but I'm not really using this for that much structural stuff here anyway. Like I said, each section of mirror is less than 5 pounds and two. What holds them in place here, each one's individually held in place. I 3D printed some blocks up here, and some of these I started with PLA. And later on, I started printing them with ABS, and I did put aluminum cap on them just to keep the UV from breaking things down. But I have no doubt that even the PLA stuff I printed was going to last for many years and too. I've used that outside of a couple of other places, and it should not be a problem. And I'm switching all over to ABS right now. So this is a picture of the my tube underneath the aluminum cap. Now look, the aluminum cap on the top serves multi-purposes. One, it is a secondary mirror. I try to get the shiniest aluminum I can there too, and it's about 2.5 inches in width, and my mirrors are 2.5 inches in width. So I've been trying to target the whole area with my mirror. That way, take a little bit more or less of air, but it's been pretty much rock solid. This tubing itself is just flat black, but you can see it here when it's in full sun. It is just like glowing. There's enough water running through it, and I'm using a mixture of antifreeze, food grade antifreeze, and water. It should take me down to 35 below then too, which is a kind of a record temperature, but it's not a drain back system. Basically, it just goes through that thermal exchange loop I have in my water tank, my preheating water tank then too. So a couple other reasons I use this cap on here too. Well, it blocks the law of the wind. I didn't want this exposed here too, so blocks the birds from sitting on it, things like that, because I put a copper oxide selective coating on this, and it's not as durable, so you need to kind of protect the thing up here too. And I did make it so there are unions, so I can actually unscrew the whole top and the whole thing can come off and be replaced with something else in too. I did make the target 3/4 inch. Okay, I used 1/2 inch PEX and 1/2 inch copper for everything, but I wanted to slow down the velocity, so I increased the area. I also took a long aluminum rod and taped some pretty aggressive sandpaper to it and reamed the inside of the copper before I put them together. There's lots of research out there talking about the more turbulence you can build up on the inside of a heat exchanger, the better efficiency of the heat exchanger is going to be at doing its job then too. So I knew the selective coating was going to work. I did some prior tests, and I talked about that too on the earlier video of how I made this coating. But I had that one mirror on there just for helping me track. In fact, here's a hint. put the mirrors on the very last. Okay, you'll be blinded by the time you get this thing done. You're working on this thing and all the sun's hitting you. So I did the whole thing, and I'm just slowly adding my mirrors to it. In fact, I still got a few more mirrors to go, and yet this has really been functional for 6 weeks. But I knew this was going to work because I had that one tracking mirror on here. Now I didn't have any fluid on here, fluid running through it. It was just getting hot. And it was tracking for, I don't know, 3 or 4 hours. And I was just working the top, and I put my finger on it to see if I could tell how warm it was. I had to take it away quickly. It was that hot. In fact, I left a little red spot. And that's just one mirror. I was blown away. Um, so yeah, it's amazing how well it is working. If the pump fails, it will be a steam generator. I know that, and that's why I have some safeguards built into it to keep that from happening then too. So um, again, I found some just 12-inch square mirrors used for bathrooms, and actually they talked about being a moisture resistant backing. That sounds perfect. I do have aluminum on the back covering the whole thing up, so I've got it kind of sealed into the different types of caulks I'm using. I've tried variations. This is my very first one I put up here, and was just put together with. I just threw it in there one day, no drain holes, no nothing. It's kind of worst case scenario, and it's been working amazingly well. In fact, I have one I just built here 2 months ago. Actually, it's starting to fail because of what I did when I always clean the aluminum up with rubbing alcohol to take off anything, and I think I got some rubbing alcohol on the back. I used 91%. I got to the back of the mirror, and I can see that sort of disrupted it, and it's starting to break down there. So word of the warning: be careful of the alcohol in the back of your mirrors then too. But I got 12-inch square mirrors. I just cut them and glued them in place, and so there's really 1 square foot um, on every piece. Okay, so there's 24 sections here, 24 pieces into. I have a total here too. And again, I still got three to go, but I'm already happy right now. Um, this is sort of more variations of it here, what I'm using here too. And I noticed, like I said, I had to go through and I had to realign these things because I used some of the different functioning I had, or the 3D printing parts didn't really hold them secure. And again, I thought I might have to cover the whole thing up, but no, it worked great. I can actually see the extra light. So even though I'm adding one every now and then, it's not that hard to do. I mean, just make sure it's functional, tracking, and honing in there. And as long as the whole thing is pointed right at it, this is like a Fresnel reflector. Okay. Again, I've seen a lot of videos out there, people using like first surface mirrors and bending plastic around, all the type of stuff here too. Well, I needed something that didn't have a whole lot of plastic. That stuff does not hold up. I've used plastic mirrors too, and first surface mirrors, you're going to be cleaning the bird poop off that and everything else, and you're going to realize, it doesn't look so shiny after a year or two. So that's why I went with glass. I can replace it. It's relatively cheap. I made some jigs to weld this thing up pretty quickly. In fact, you can tell I did not spend a lot of time cleaning up the welds and all that here too. So but yeah, the cost was not too much for one. I think I got something they're under $20 a piece, with all the parts, all the mirrors, all the caulk and everything I figured up then too. So yeah, it was a little bit investment, but then so was my 40% of the heating of my house every year. So anyway, this is my water pump. And again, this is powered by the solar downstairs, or by the solar outside, I should say, the 100 watt panel in too. This is the output, and you can see here I have another valve down here in the bottom, and then I have a check valve here. Sorry, I have I can turn off the flow right here, and then another place I can put my tubing onto here as well. And what I did, I hooked tubing up to the fitting in the top here, and I took this picture after I'd already taken this other tube off the bottom one here too. So there's a spigot down there I can connect it to. And what I did, that little pump will not pump the water through, and all the loops and curls and everything. You need something really with a lot more psi, a lot more headspace to be able to push that much fluid through. And so once I finally got this thing going, sure enough, I ran it for about 5 minutes, just getting all the air bubbles out. I even used this pump, shutting the valve, to build the pressure up in the system. I'm running about 40 to 45 psi for a couple of reasons. And that actually worked really well to do that. I got it up fairly high, and I used my expansion tank to get the rest of the pressure I wanted in too. So once this was done, I disconnected everything, turned the valve back open here, and yeah, I don't think I have any air in the whole system here too. Now I am using this orange stuff. That's the PEX. That's PEX Alpex. Okay, which means it's got aluminum built inside of it. Okay, and a couple reasons for having that: one, you don't get the thermal expansion. It doesn't go crazy with heat as a normal PEX, and two, it actually prevents oxygen from getting into it. And if I have anything like, I'm not sure about my heat exchanger inside in the tank here. And so anything that's metal, like my pressure tank, whatever, expansion tank, you need to limit the oxygen because that will actually help. It'll start breaking things down then too. So the Pexal PEX was a nice solution here too. And again, I think Pexal PEX is rated 160 psi at a pretty good temperature at that time, but well beyond what I'm using here too. So anyway, this is my control box. I'm still in my basement here where my 80-gallon tank's at. I did add a little diode here. Anytime you're actually shutting off a motor, you're going to that collapsing magnetic field from the motor is going to cause a spike that could damage your solid state relay. So I got a pretty good size diode in there too. And I did separate my wires here. I was getting some interference from my temperature sensors, which don't really have the best insulation from noise, so to speak. So I did separate them from the power lines and things over here too. So that really kind of helped them, because I'm probably running on my temperature sensors probably 80 feet of line, and all these sensors are set all over the place. So yeah, I had to take some kind of pains. In fact, the bundle of wire I had here actually has some insulation on it too, and some electrical insulation, shielded pairs. So that was a good wire I found to use for that too. So this box will be mounted on the wall, but if I mounted it right now, you wouldn't be able to see anything. So that's why I'm doing these videos here before I get them all buttoned up so you can see what I've done. Now I'm using the temperature sensors I talked about. These are these Dallas 18B20. I really like these things. You can just use 3 wires, voltage, ground, and the signal wire, and you can hook these temperature sensors all along that system here too, and they all report. They all have a unique code or unique number, and so it makes it real easy to tell what comes what's reporting here, all from a 3-wire bus. And that's what you're seeing underneath this aluminum foil here. I just wrapped it up with aluminum foil to help transfer the heat a little bit easily here too. Now I am not using, this is actually the return from my collectors, and I'm not using a check valve. The my solar trough is actually slightly below this height, and so I'm not going to get any thermal siphoning, and I don't think I am then too. So I took all the PEX line and my electrical conduit and all that. Actually, what you see this tubing come out here is aluminum flashing, but what is underneath of that, I used the PVC waste vent. A pretty good size one, because it took a lot to get everything in there. I have the PEX lines. Both are foam wrapped, and then also wrapped with a foil insulation on top of that. Then also all my wires coming through it as well. And down here I have a junction box all the wires head into that helps control things here. This is what I'm actually using it more just for a breakout box then too. I did make a video of how my tracking system works, and that does extremely well. I'm just impressed how good that thing works then too. And on this PVC waste drain line here, I put aluminum on top of that as well, the aluminum foil, aluminized mylar, but then I also wrapped it in aluminum flashing. I figure it's going to hold up a lot better than weed whipping or whatever here too, than anything else in too. And you've got to cover up anything you possibly can because of UV exposure. I try to minimize my use of plastic here, or use the stuff that will hold up to a little bit. And I'm still thinking about maybe putting some type of UV shield and things down here. But even though this is PVC coated, it's actually PVC coated metal too. So Nothing really flexes here. It's just basically the flexing of the coupling here too, of the Mosmatic. Now I do have sensors here as well on both ends, and yes, it would have been better if I would have put the sensor at the top up here. I would get a little bit more accurate, but then I'm flexing the wire back and forth, and so I figured I'm just going to leave the sensors static. It won't be the best reporting, but it's going to give me. I mean, I can learn to live with that. Put it that way then too. So, this is my control system in my greenhouse. I figured it's a good place to put it. If I do have a leak, well, this place is used to water anyway. Again, I've not put the insulation on here yet. I've got to finish that up here too, but I want to make sure people can see things. They can learn anything about what I'm doing or use. I want to use anything. You have to have an expansion tank, of course. You do get changes in pressure proportional to temperature, and when you increase your fluid, you're going to increase your pressure then too. And I do have a gauge up here just for viewing it, but I also have a pressure transducer right here. Okay, and that pressure reports down to my Arduino. I'm using an Arduino Mega. Okay, I needed the extra ports, and I have another project. The dual axis, two-axis project, but right now this is what I'm using, and I will release the artwork for the board. I had to make a shield for this one as well. I will also release the code when I'm done, if I'm ever done then too. So, but the reason I'm running 45 pounds, okay, one, it increases the temperature of the boiling point, okay, so in case I ever have a problem there, but also because my pump does not like to run dry, you'll probably heard it. If I ever see a temperature loss, or sorry, if I ever see a pressure loss, okay, I can shut the whole system off and actually take the collector out of focus. So it's not going to be a steam generator, and that's going to save my pump and probably save my line someplace here too. Even though I do have up here on the top here too, I do have a pressure relief valve here too. If the pressure goes over too high, it will exit out that and hopefully save it from breaking someplace else then too. So I put another valve up here too. That was for, I might be adding an air purging system here too, but we'll see if I need that or not then too. But it's easier to do it now than later on when I wanted to redo it. I'm using solid state relays down here to control the pump. The solid state relay actually controls fans going to the photovoltaic system. That is currently offline. I had that running directly on the PV, but I've actually had to put this system back up, and I will be adding that to it later on here too. I like these Jenison controllers. In fact, this whole system is actually running off this battery down here, with the exception of my Arduino. It was all running off solar. Okay, but I was using these 78 LM 08 voltage converters, but the linear series, especially when you're talking about this much power, they get hot. I mean, even having them heat sinked and all that, they're still pretty warm. And I was getting fluctuations of voltage, I thought. In fact, my A to D was kind of all over the place, and I figured it had to be my voltage supply system. So the minute I plugged in this wall wart, and it took all those problems away. Okay, so now I got rock solid A to D reporting. And I might switch back to solar someday, but right now I have enough going on here too. So, but I'm using the Jenison controllers here. I really like them for the batteries. I've used them before. They're just rock solid. I like the Spark. These are the Rev Spark motor controllers. This is actually what controls my linear actuator on my collector to bring things up and down all the time here too. I'm not even using the big one because this is really kind of a small system. It's a small motor. Yes, it's all fuse protected. I have a voltage meter right here. I can just push the button and see the voltage here too. I have some cutoff switches if necessary. I can take the whole thing offline. And even though I'm using this wall wart, I'm guessing it probably uses $4 a year for the whole system here too. So actually it's not that expensive to use. I did have, since I'm using a battery, and I did have an extra little USB charger or USB converter from 12 volt. I went ahead and plugged that into it and made it, and now I have a solar powered Alexa out here too. I can listen to things when I'm working there too. So, but anyway, that system, this has been working well, and I'm really glad I did not put the insulation on too. I found on some of these connectors, two of these connectors, the copper, they've had a small, very small leak. Not enough to really interfere with my dropping my pressure, but it probably would have in time. So now let's back up 1 second. I have a 3-button system here. Now the yellow button is the screen advance. Every time I push that one, I can advance to the next LCD screen. And then buttons will do different things salient to what their screen is. So the red and the green then too. So what I have in the first, this is kind of the first default screen. This tells me what my PV temperature, the photovoltaic temperature is, and whether my fan is on or off. Right now that system is not functional. It also tells me the tank in temperature. This is my hot water tank. Also tells me my tank out temperature. My collector in and collector out. Now things are just starting. This is early in the morning here too, and things are just starting in this picture here too. This is my first area. I mean, I've gone through 15 different reversions of software, and this is going to be another one. But the problem I see right now here, okay, why I point this out, this pump is all controlled by light intensity. What I really need to do is actually incorporate that now into what the tank out, because right now I'm taking heat from my tank to run through the system, and so I really shouldn't have this pump on. So it's on my to-do list. I'll get that here too. But again, this is my 41 psi. I can monitor that. If it gets too high or too low, something will happen. Shut the whole system down. Take the whole system offline, out of focus. Now this is just the next screen. Tells me the readout from my tracking system. And right now I think I have it set up if it's within 8%. If the number is 8% of each other, they're not going to move. It's going to be close enough within tolerance here too. And sure enough, these are pretty close right here. Also gives me reporting on the tilt switches. My whole system will move fully with the full extension and full contraction of the linear actuator, but I wanted to minimize how far to go down based on how far the sun will go down in the wintertime here too. So that's what the tilt switches were then too. And again, I detailed how I did that more in my tracking one then too. So now this is the I had to use this Tyco servo because I found out that there's a little glitches when it comes to the interrupts when it comes to using servos sometimes with LCDs. And so this is the first little hint I had. Use this for your servo controller instead of just a normal servo controller. It'll take care of a lot of problems, especially if you're using it for the megas here too. So otherwise I was getting a little ink every few minutes as the interrupt would be taking over for something. And so this actually took care of all those problems. Okay. This is the override system. If I push the red button, it goes up. If I push the green button, it goes down. Also reports in the tilt switch status then too. So PV temp I can control. And again, this is something I really need to do because I can normally hit, if it's a sunny day, I'll hit 120, 100 some, almost 130 degrees on the PV. And that's probably decreasing the efficiency by around 10%. And so, yeah, if I cool these things down with the fans, I can really increase the efficiency of how well they work. So, yeah, not too much of a problem in the wintertime, but summertime it's a problem. Okay, here's the board down here. I did post this particular little 3D printed USB power supply on Thingiverse and too. So, but I will be releasing the code and artwork when I get this all done. But this is certainly a work in progress. But it's been up and running for 6 weeks now. And I can tell that, wow, it's been doing great temperatures. Like I said, my high temperature has been 155, but it's normally, any sunny day, I'm 130, something like that or two. And if it's a good sunny day, and I'm not even got all my mirrors on it yet, so I can't wait to finalize this thing here too. But anyway, I just wanted to kind of post this and keep people up and running if they've actually seen the first 2 videos then too. So I will do one more when it comes to the final software, getting it all taken care of here too. So. But yeah, I realize this is not a starting project for people, but this is it's not always the destination. Sometimes it's a journey, and I really enjoyed this one. So anyway, hope it helps.